looking at today is graphs of equations. Sketching graphs, we're not actually going to be sketching any graphs. I'm not going to have you sketch graphs, but we are going to identify x and y intercepts of graphs, symmetry, and doing some with equations. Now, the graph equation can be used to represent an equation visually in respect to two quantities. Normally, we're talking about with this here is y equals 7 minus 3x, where we're seeing the solutions in terms of our x and y, a value for a or a b. So a value given this for x, when we plug it in for x, we get an output b. And it is a true statement. For instance, 1,4 is a solution of this equation y equals 7 minus 3x, because if you plug 1 in for x, the y value, the output is indeed 4. So it makes a true statement. And the graph of an equation is a set of all points that are solutions to the equations, all points on a line. So if we want to determine if 213 and -1, -3 lie on the graph are solutions to this here, well, all we have to do is take 213. We're going to plug 13 in for y, 2 in for x, and see if we do indeed get a true statement. Well, 13 is already by itself. We don't have to do anything for the 13. Now here, 10 times 2 is 20. 20 minus 7 is 13. So it does make a true statement. It does lie on the line. So 213, yes, that does lie on the line. It is a point on the graph. It does give us a true statement. Questions on this so far? We can do the same thing with -1, -3. So we plug -3 in for y, plug -1 in for x, and see if we get a true statement. Get both sides to be equal. Now the first thing we can do is 10 times -1, which is going to be -10. -10 minus 7 is -17.
May I have your attention? May I have your attention, please? I need the student council to report to Mrs. Sykes' room at this time. Student council. Thank you.
-3 is not equal to -17, so no, that does not lie on the line of this graph. It does not give us a true statement. Questions on this here? Not too bad. So graph of equation, if we're going to graph it point plotting method, when not possible, isolate one of the variables, get it as y equals x equals one of the two. Construct a table of several values, plot these points, and then connect the points to make a curve or straight line. So what this is saying is if we took this here, y equals -3x plus 7, we have the variable by itself. So because this consists of several points, what we'll do is make a table. So -1, 0, 1, 2, 3, 4, and we plug those numbers in. -3 times -1 plus 7. 3 plus 7, y is equal to 10. So we have the point -1, 10. And we do the same for 0, 1, 2, 3, 4. And once we get all those points, we plot them on a coordinate plane and draw a line. I mean, that's it for graphing. We've done graphing. Y'all done it. It's just been years. Not all we're going to say with graphing. Intercepts of graphs. Now, the intercept of graph is verging across the x or y axis. That's all an intercept is. It's often easy to determine the solution points that have zeros as either the x-coordinate or the y-coordinate. These points are called intercepts because they are the point at which the graph intercepts the x or y axis. Yeah. No, I didn't put everything in there. Because not all of this, trying to save a little bit on paper, because we know what an intercept is. It crosses the x or y axis. It is possible for a graph to have no intercepts, never crosses the x-axis. We looked at this especially in Algebra 2, because that ended up having imaginary solutions. This is where our solutions with I came into play. Or we could have, say, 3 intercepts, because it crosses the x-axis in 3 locations. And this has 1 y-intercept. Now this first one does have a y-intercept, just no x. Or here we can have 1 x-intercept and 2 y-intercepts. Now this is not a function, but it still works. We can have an equation for it. Or we can have the case like this here, this circle, where it doesn't cross either axis. So there is no x-intercept or y-intercept. Note that an x-intercept can be written as a comma 0 because the y value is 0 at the x-intercept. And the y-intercept can be written as an ordered pair 0 comma b. So unless it's a necessary distinction to tell the intercepts, we refer to them as x-intercepts, let y be 0, and y-intercepts, let x be 0. So for this first one here, to find the x-intercepts of the graph, y equals x cubed minus 4x, let y be 0. So what that's saying is we're going to replace y with 0. And we want to solve this here. We want to solve this to see what values of x will make the y value be 0. Now with our higher degree polynomial functions, the degree is going to be equal to the number of solutions. So the degree for this here is 3. It's our biggest exponent attached to the variable. So we should have 3 solutions. Now we can do this by factoring. Is there a greatest common factor? Is there something in common with both of these terms? X. And we can factor that greatest common factor out. Because if we factor x out of x cubed, we're left with x squared minus 4. And luckily for us, x squared minus 4 does factor. It is one that is kind of nice. It's our difference of perfect squares. Because it's our a squared minus b squared. So I'm going to write this to the side. Our difference of perfect square formula, a squared minus b squared is equal to a plus b times a minus b. Yes, sir? Yes. And for us here, our a term, our a squared, is our x squared. Well, what multiplies by itself to give us x squared? X and x. What multiplies by itself to give us 4? And 2 plus and minus. Questions on this so far? Now the reason we factored this and wrote it out this way is now we have, oh, I got a highlighter out. I have 1, 2, 3 things being multiplied together that equal what? 0. Whenever I multiply 2 or more things together and it equals 0, one of them has to be 0. So what it's telling us here is that either x is equal to 0, x plus 2 is equal to 0, or x minus 2 is equal to 0. One of these is nicer than the other two. X equals 0. If it's done, x is already by itself. This next one, x plus 2, well, we have to get x by itself, so we'd subtract 2 from both sides, telling us x is equal to 2. Yes, thank you. It would be negative 2. Add 2, telling us x is equal to positive 2. So our x-intercepts are at 0, negative 2, and positive 2. And that's it. And since we're looking for x-intercepts, we can just list this here. The actual points would be 0, 0, -2, 0, and 2, 0. Because we're looking for what values of x will make the y value be 0. Questions on this here? X cubed minus 4x. We can graph it and we see that at -2, 0, and 2, the y value is indeed 0. So graphically, we do have it too. Questions on finding the x-intercept. Really, it's just solving the equation like we've done before. 0, and we have it here. Now, the next one we're looking at is to find the y-intercept of this graph. This time, I'm going to take this equation, but instead of replacing x with 0, we're going to replace y with 0. Or sorry, instead of placing y with 0, we're replacing x with 0. This is even nicer. What's 4 times 0 cubed? So this whole side becomes 0. So the y-intercept, the value where it the y value where it crosses the y-axis is 0. If we're talking about the point, it is 0, 0. So sometimes one is nicer than the other. Yep. Has one solution, 0. That's 0.00. Questions on x or y intercepts? Symmetry. Graphs of an equation can have symmetry with respect to one of the coordinate axes or respect with the origin. Symmetry with respect to the x means that when the Cartesian plane were folded along the x-axis, it would mirror itself across that side, like this here. Or if we're talking about symmetry across the y-axis, it would mirror across like this here, negative x, comma y, x, comma y. Or across the origin, really we have this double flip. So basically, if we're going to test for symmetry, we have this here. A graph is symmetric with respect to the x-axis if, whenever x comma y is a solution on the graph, or x comma y is on the graph, x comma negative y is also on the graph. The graph is symmetric with respect to the y-axis whenever x comma y is on the graph, and negative x comma y is also on the graph. The graph with respect to the origin, x comma y is on the graph, and negative x comma negative y is on the graph. So, if we can do this, and we look at this here. Now, graphically, if we look at this equation, we can see that this is symmetric across the y, because every point on the left and right is flipped. As it doesn't matter if x is 3 or negative 3, the y value is still 7. 2, negative 2, it's still 2. Negative 1, 1. We still have the same y value. So you can conclude that this here is true because x comma y is a point, and also negative x comma y is a point. And one way we can see this is by replacing x with negative x and seeing if we come up with the same equation. Because negative x squared, whenever we multiply negative by itself, it becomes positive. So we get back to y equals x squared, which is the same equation we started with. Now we already said that this is symmetric to the y-axis. It is not going to be symmetric to the x. Because if it was symmetric to the x, we could replace y with negative y and end up with the exact same equation. So I replace y with negative y. So it tells me negative y is equal to x squared minus 2. To make the y positive, we're going to divide everything by 1. So negative y divided by negative 1 does give us y. However, our x squared divided by negative 1 is now negative x squared, and our negative 2 has now become positive 2. Is this the same equation we started with? No, because the x squared is now negative, the 2 is positive, so it's not symmetric across the x-axis. It's not symmetric in respect to x because we do not have that flip. It's not the same equation. If it's going to be with respect to the origin, if we plug negative x and negative y in, we should get the same equation. Let's look at another example of this. Or this is essentially what it is. The graph of an equation is symmetric to the x-axis when you replace y with negative y, and we yield an equivalent equation. The graph is with respect to y, if you can replace x with negative x and get back to where we started. And it's with respect to the origin, if you can replace x with negative x and y with negative y and get the starting equation back. So let's look at this here. Now we're not going to sketch it. We'll sketch it in a minute, or it'll sketch it. But if we want to see if it's symmetric to the x-axis, so x-axis, what we're going to do is we're going to replace y with negative y. So here, we're going to take the y value and replace it with negative y. And see if we get the same equation. Now we can drop the parentheses, and we have negative y is equal to the absolute value of x minus 1. To get the y positive, we can divide both sides by negative 1, which will tell us that y is equal to negative x minus 1. Is that the same equation as what we started with? No. So we cannot say that it is symmetric with respect to x because that's not the original equation we started with. The next one we can look at is the y-axis. And with the y-axis, we replace x with negative x. Now at this point here, we can drop the parentheses, which will tell us that we have negative x minus 1. This here. Is that the same equation that we had before? Because our original equation was what? Absolute value of x minus 1. Here we have negative x minus 1, yes? Now there are some ways to manipulate it in that, well, I could factor a negative 1 out to try to get that x back positive. And it does make it positive, but now we have what? Plus 1 instead of minus 1. No matter what we do from here, that's not the same equation. So we can't say it's symmetric with respect to y. Now the only other option is the origin. And with the origin, we're going to replace the x and y with negative. So negative y is replacing y, negative x is replacing x. Again, we can divide by negative 1 like we did last time. and there's no way for us to get rid of that -1 out front, that negative out front. So again, this one here is not symmetric to the x, y, or origin. So this is none. It doesn't have it to be symmetric to one of these, because it could be none. It could be one of them, or this here. So this equation fails all three tests, and consequently its graph is not symmetric with respect to either axis or the origin. And if we looked at the graph here, this is what we have. So it's not symmetric to x, y, or the origin. Now we're not going to sketch it, but we are going to test to see if this is symmetric to the x, y, or the origin. So we're looking at this here, y squared equals 6 minus x. So we can start with respect to the x-axis. So if it is symmetric with respect to the x-axis, if I replace y with negative y, we'll get back to our starting equation. So we'll have negative y squared is equal to 6 minus x. Well, negative y squared, negative y times negative y, is just going to be y squared. Is that the equation we started with? Yeah. So it is symmetric to the x-axis. And that's it. And we don't actually have to test anything beyond that, because this here did tell us it is symmetric to the x. We are done. Because if we check the y-axis, we replaced x with negative x. That will just tell us that y squared is equal to 6 plus x. That is not the equation we started with. And even if we check the origin, it will just tell us that y squared is equal to 6 plus x. And again, not the equation we started with. Questions on this here? All right, we want to check, see which is symmetric here. So again, if we're doing the x-axis, we're replacing y with negative y. So when we replace y with negative y, we get this here. Negative y equals 2x cubed. Now we can try making the y value positive by dividing both sides by -1. But that just tells us that y is equal to negative 2x cubed, which is not our starting equation. So this here is not symmetric to the x-axis. Now if we check for the y-axis, this time we're going to replace x with negative x. So this time we have y is equal to 2 times negative x cubed. So we're going to multiply negative x by itself 3 times. Well, the easy part, x times x times x, we do indeed get our x to the third. And we will still have our 2, but the main question is that negative. Now, negative times a negative squared is a, if we multiply it by a negative one more time, it comes back negative. So our negative x to the third power is just negative x cubed times our 2 tells us it's negative 2x cubed. Is that the equation we started with? No. So it's not symmetric with respect to the y-axis. Now it leaves us with the origin, respect to the origin. Now this one here, we replace y with negative y. And we're going to replace x with negative x. Now here the nice y is just going to be negative y is equal to, as we just saw, 2 times negative x to the third power becomes negative 2x cubed. Now, if we want to make the y positive or x positive, we can divide by this negative 1. Because our negative y divided by negative 1 is y. Negative 2x cubed divided by negative 1 is 2x cubed. Is this the equation we started with? Yes. So it means y equals 2x cubed is symmetric with respect to the origin. Because what it's saying, is that the point x comma y is a solution, and the point negative x comma negative y is a solution on this graph. Questions on this here? Last thing we're talking about is circles. Consider the circle shown in this figure here. Point x comma y lies on the circle if and only if the distance from the center is r. The distance formula we have here, we worked with it in the first section. By squaring each of the sides, you can obtain the standard formula of the equation of a circle. Our standard formula for the equation of a circle is given by this here, x minus h squared plus y minus k squared is equal to r squared. H comma k is the center and r is the radius. Now this is very nice because if we're trying to find the equation and they give us the center and the radius, all we got to do is plug it in and we have our equation. That's it. Like this here, they gave us the center and the radius. Or they gave us the center of the point on the circle. All we need to do is find the radius, and we get there. 3, 4 lies on the circle, whose center is at negative 1, 2. As shown here, write the standard form of the equation. Now, the first thing we need to do is find the radius. Because here, x minus h squared plus y minus k squared is equal to r squared. Now the center was told to us to be the point negative 1, 2. So this here is our h comma k. So for this equation, we have x minus our h value plus y minus our k value is equal to whatever our radius is being squared. So we're just plugging in the numbers so far that we have. Now we'll have to do some simplifying. But the only thing we're missing is the radius, the distance from the center to a point on the circle. But that's not too difficult to find because distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now the order in which we put the x values and y values doesn't matter for this here because we are being squared. It's being squared. Because at this point we can do it by hand. Now let's look at this here. What is negative 1 minus 3? Negative 4. Here, 2 minus 4 is negative 2 squared. Negative 4 squared is. Negative 2 squared is. 16 plus 4 is. 20, yes? Now we can leave it as that there and plug it back in. Now in most places, in most cases, we would want to simplify that radical to 2 square roots of 5. Here, with finding the radius, or, well, not so much finding the radius, we want to find the equation. That's what it asked, yes? It didn't ask for the radius. It didn't ask for what the center is. It just wanted the equation, yes? What do we have to do to the r value in the equation? We have to, we have to square it, yes? What's the square root of 20 squared? So is there any reason to simplify to 2 square root of 5 to square it? No, because that's nicer. Squaring the square root of 20 is a little bit easier, a little bit nicer than trying to square 2 square roots of 5. Now our negative is going to make a plus, telling us x plus 1 squared plus y minus 2 squared is equal to 20. And that's it. Questions on this here? Any questions on anything we've done so far? So here they did the distance formula a little bit different. Instead of having negative 1 minus 3, they did 3 minus negative 1. Well, 3 minus negative 1 is 4. 4 squared 16. We still get the same point. 4 minus 2 is 2. 2 squared is 4. Get the same spot. And it tells us that our equation is x plus 1 squared plus y minus 2 squared is equal to 20. That's it. Questions on this here? All right. Last problem that we're going to do here. Find the equation of the circle from the endpoints. This is the hardest one with circles because they gave us the diameter. They did not give us the center and a point on the circle. So the two things we need to find are the center and then the radius. I find it's easier to find the center first. Because the center of the circle is going to be the midpoint of the diameter. Because the diameter connects 2 points on the circle and goes through its center. So we can use the midpoint formula, which is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Now here 13 plus 3 is 14. Negative 5 plus 15 is 10. 14 divided by 2 is 7. 10 divided by 2 is 5. Which tells us that the midpoint of these 2 points is 7, 5. Or that our center is the point 7, comma 5. Now that is helpful for us because it tells us that our x minus h would be x minus 7 squared plus y minus k would be y minus 5 squared is equal to our radius squared. So the only last thing, or the only thing we have to find now is the radius. Now we can get the radius from the diameter. We can use the distance formula, but once we get that answer, we're going to have to divide it by 2. We have to cut it in half. But I think it's easier to go from the center, our 7, 5, to one of the endpoints. Now it doesn't matter which endpoint we use, we just got to pick one of them. I'll pick 11, negative 5. 7 minus 11 is going to be negative 4 squared. 5 minus negative 5, then negative and negative makes a plus, giving us 10 squared. Now negative 4 squared is going to be 16. 10 squared is going to be 100, telling us that our distance, our radius, is the square root of 116. Now that can simplify. We can reduce that radical, but again, there's not a whole lot of reason to, when the next thing we're going to do is square it to get the formula. Telling us that our final formula is x minus 7 squared plus y minus 5 squared is equal to 116. Questions on this here? Now what's interesting with this formula is if I chose the other 0.35, 7 minus 3 is what? 4. 5 minus negative, or 5 minus 15? Negative 10, yes? Well, 4 squared is, negative, 4 squared 16. Negative 10 squared is 100. We get to the same point. We get the same distance. The numbers inside those parentheses, the sign changed on them, but because we square it, it makes it back positive. It doesn't make a difference. Questions on this here? We're ready for what's next. Yep. I'm not too concerned with that there. And that's it.